Norms flouted, tectonic fault lines ignored, lapses in Uttarkashi tunnel collapse. On-site investigation coupled with open-source intelligence reveals the alarming lapses in the construction of the Silkyara tunnel where a collapse entrapped 41 workers on Diwali. In short, major safety lapses by construction firm, Navayug Engineering. Geological risks ignored. Need for responsible construction. The agonizing 17 days in the rescue operation in Uttarkashi, aimed at saving the lives of 41 workers who got trapped following a collapse on November 12, has brought the spotlight on the alarming lapses in safety protocols by the company overseeing the tunnel's construction, Navayug Engineering. A comprehensive assessment conducted by India Today's open-source intelligence team and corroborated by on-site observations has brought into light several breaches of regulations by the contractor. These lapses give rise to a number of significant questions that may get buried in the debris of the mishap. The 4.5-kilometer tunnel, which is part of the government's Char Dham Pariyojana to improve connectivity to 4 pilgrimage sites in the state, is located in the Uttarkashi district. It is being constructed by the National Highways and Infrastructure Development Corporation Limited, set up by the Union government in 2014. Unstable topography. Despite the tunnel's relatively shallow depth of 140 meters, it is important to note that Uttarkashi is situated in the upper Himalayan region and is in proximity to the main central thrust. This geological fault line is where the Indian peninsular plate is pushed beneath the Eurasian plate, stretching over 2,000 kilometers along the Himalayan line from northwest to southeast. Consequently, the area experiences significant shear stress due to continuous tectonic plate movement. In an interview, noted geologist and Professor Dr. C.P. Rajendran told India Today that Uttarkashi and surrounding areas have previously experienced some major seismic activity, including a 7.8 magnitude earthquake in 1803 and a 7 magnitude earthquake in 1991. A shear zone is a thin zone within the Earth's crust or upper mantle that has been strongly deformed, due to the walls of rock on either side of the zone slipping past each other. In the upper crust, where rock is brittle, the shear zone takes the form of a fracture called a fault. The methods used to protect weak sections depend on the length and strata of the shear zone. This includes the use of forepoles, rock bolts, steel ribs, or shotcrete to reinforce the zone. Geologically, the barcode thrust belongs to the category of thrust faults, which are fractures in the Earth's crust characterized by the relative movement and displacement of the adjoining rock layers. Thrust faults often develop in areas with compressional tectonic forces, where forces act to push two sections of the Earth's crust into one another. The movement along these faults can take various directions, including horizontal, vertical, or oblique, and they play a significant role in shaping the Earth's crust and geological landscapes. Tunnel seismic prediction, which involves a seismic survey before initiating a new phase of the tunnel and also helps maintain safety during construction, was not taken into consideration in case of the Silkyara tunnel, Dr. Rajendra said. TSP is used to analyze what lies 100 meters ahead of the completed zone. Norms flouted following the guidelines set forth by the National Safety Council and outlined in the Bureau of Indian Standards for the construction of two-lane bidirectional tunnels. We conducted a thorough examination, aligning with the actual conditions on the ground. 1. Absence of escape route. One major lapse on the part of the construction company was that it did not create a safety exit route. As per the standard operating procedure, tunnels exceeding a length of 3 kilometers are required to incorporate an escape route to ensure the safety of individuals in the event of a disaster. On-site observations have revealed that, according to the proposed plan, an escape route was indeed planned for the 4.5-kilometer Silkyara tunnel, but it was never implemented. Such escape routes are meant to be used even after tunnels are built to rescue people passing through them in vehicles if there is a collapse, landslide or any other disaster. As per the map, which hints that an escape route was planned, a 400 mm concrete false floor was also planned in the drift tunnel with pipe roofing, but no such flooring exists either. 2. No mentioned use of trench cages. On-site reports have revealed that no trench cages or safe tubes were used for the workers walking in unprotected parts of a trench. Trench cages serve a crucial role in safeguarding workers from potential cave-ins. However, they are not designed to shore up or provide support to trench walls on their own. Previously, the workers accused Hitler officials of ignoring the safety guidelines, which led to the incident. Recent videos from the Uttarkashi tunnel rescue operation show that now rescuers are using such cages to work inside the tunnel. 3. Ambiguity on SOP. Ambiguity arises in the standard operating procedure regarding tunnels, particularly in the case of steeply inclined tunnels. The tunnel guidelines stipulate the provision of steps for rapid evacuation in the event of haulage failure. However, officials say that the railways is the only entity mandated to construct escape micro-tunnels with stairs, given the presence of rail tracks on the surface. For two-lane tunnels, the SOP lacks clarity on whether steps shall be provided for quick exit is obligatory. 4. Absence of Hume pipe. The workers say that the Hume pipes which were placed after one of the earlier accidents had also been removed even before the completion of work at the tunnel. Hume pipes in tunnels are concrete tubes that run the length of the tunnel during the construction phase. These pipes meant for rescue in case of tunnel collapse were removed while a significant portion of the work was still left, accounting for gross negligence on the construction firm's part. Such pipes also work towards eliminating the toxic gases produced during the construction of tunnels. Defying science of the Himalayas, it is a known fact that the Himalayas are a young, unstable, and highly fragile mountain range. It has an active fault line and is more seismically active than the Alps in Europe, which are an older mountain range. How does this translate to building rampant roads, tunnels, and dams in the Himalayas? It suggests that the Himalayas are more susceptible to excessive and unscientific construction work. The extensive land subsidence in Joshimath that destroyed property and livelihoods earlier this year, the flash floods over the years at Kedarnath, Ladakh, and Sikkim, and the hundreds of incidents of landslides across the Himalayas, all of these are linked to reckless and uninformed construction work. The Silkyara tunnel is part of the government's prestigious Char Dham Pariyojana, which aims to widen 900 kilometers of road in Uttarakhand by 12 meters. The stated aim is to allow more devotees to visit the holy shrines of Uttarakhand, and in the process, uplift the state economically. There is absolutely no problem with the aim. But if we ignore the science en route, then the plans can turn to rubble. Justice U.C. Dhyani, who was a member of the Supreme Court-appointed high-powered committee, pointed out that his committee's recommendation of building a narrow tunnel of 7 to 8 meters wide has been ignored, leading to more blasting and increased risk of collapse and widening the road by 12 meters. What do experts say? In a joint statement, 11 trade unions and sectoral federations expressed their anguish at the failure of the authorities to take responsibility for the Silkyara tunnel collapse. Accidents at workplaces expose the weaknesses of laws in regard to workplace safety of workers. Rather, the laxity and violations of whatever existing norms are there get exposed with every incident. The latest, the Silkyara tunnel collapse, is only one in a series of such accidents, the unions said. Follow Live, Uttarkashi tunnel rescue. When asked if the absence of an escape tunnel is complicating matters in the ongoing rescue operation, international tunneling expert Arnold Dick said such a way out was not needed. So, normally around the world, we don't build our tunnels anticipating them to collapse like this. What we do is put escape tunnels at the end. So, if there is an incident, users can escape. My understanding is that the final design has that, but when we are constructing, we normally don't do that, he explained. Interestingly, the trade union, citing on-site workers, said that the escape routes were not even planned. They were provided when the 9 kilometers long Chenani Nashri tunnel was being constructed in JK. The trade unions further said that serious concerns have been raised by an expert regarding toxic gases being generated inside the tunnel. MP's Bisht, another geologist from Uttarakhand, stated, when undertaking such massive engineering projects, it is of utmost importance to conduct thorough geotechnical and geophysical mapping of the specific rock on which the tunnel is to be constructed. What is the future of tunneling? In an interview with geologist C.P. Rajendran, we questioned him on the future of infrastructure development and tunneling in India's northern borderlands. China's vigorous construction of roads and tunnels near the Tibetan region over the past decade has heightened the need for India to bolster its presence in the northern frontier. Nevertheless, as highlighted by the noted geologist, the geological makeup of the Himalayas on the Indian side is notably less robust compared to the Chinese side. Consequently, a cautious and restrained approach to development in this area is advisable, taking into account the region's geological intricacies. According to him, the following points must also be assessed before such projects are planned. In-depth geotechnical studies. It's imperative to conduct comprehensive geotechnical investigations, including petrographic analysis, as a prerequisite before initiating tunnel projects. Currently, in India, the tunnel design and construction occurs simultaneously, which needs to be revised. Ongoing monitoring. A specialist geologist should regularly visit the construction site to assess potential risks and determine the rock's stability over time. Adequacy testing for tunnel supports. Essential tunnel supports like shotcrete, rock bolts, steel ribs, and tunnel pipe umbrellas, and cave-in protection must undergo rigorous testing to ensure their adequacy, thus preventing any collapse. Emergency evacuation plans. In preparation for any potential collapse or disaster, arrangements should be made for the presence of National Disaster Response Force personnel and appropriate safety equipment. Construction companies bidding for such projects should include comprehensive safety plans as part of their proposals. These measures collectively contribute to safer and more reliable tunnel construction practices.